Pardon. The book is in Finnish, but then it looks like I've translated the exercises. I don't even remember because I did it in summer. That was a long time ago. So this is the course book and the book that I do in Finnish. And I didn't try to get any other book because I didn't have time. And also because they have purchased us. Oops, what is this? Assignments. This is maybe supposed to be there. Okay. The solutions now I have already for this book, which is a really big thing, but they are in Finnish. But most probably you have some kind of equipment. Everybody here who is studying this whatever thing that he translates instantly translates. Yes. Yes. So, but then those exercises that we will do here, I will of course do here, just like I do in the math as well. So I just write them. But then if you want to do some other exercises from the book, I only translated the ones that I was thinking that we go through here. And then, of course, if you want also the solutions, if you do some like extra, they will be in Finnish. Yes. So then we start with the very basic chemistry. And then we even go to mole calculations, the amount of substance. This is for sure something that you've done before as well, yeah? So most probably for you now, this is pretty easy again. Because I have then two groups in Finnish that are almost 50 in a group. So then there is a lot of people who didn't do any chemistry like ever or something. So then it's like pace is quite slow and you can't do much at the time. So this is the thing. This. Ah. So again, the course book is in Finnish. And then anyhow, if you want to, because of course, this is a subject where you can study this in from the book. And this book is pretty good. And this is also made for Polytechnic. So it's sort of low level. It's sort of also a bit irritating because it goes through certain things really fast and it doesn't explain them much. So then it might be also difficult to comprehend them. But it's so basic stuff that you can find for sure. If you want to know more in English, you find these videos, zillions, good videos in YouTube for sure that explain all this pretty nicely, some Khan Academy or whatever. So most probably even if we would have some book, maybe in the library, I don't know, most probably you don't have this kind of Polytechnic book, simple book in English. The books the chemistry books are maybe the university level chemistry books, then you can find all the information in You can even ask the friend, for sure the friend will tell you if you want to know more about some subject really easily because we don't go deep into anything. Okay, so then now we would do the exercises 1 to 4, and then I'll write it somewhere. Okay, so the first exercise sheet, we still go to the another exercise sheet. So we would do 1 to 4, and then whatever. Maybe the 8 is good as well. The 9, from the 9 we can do, for example, A to C, just to know what these things mean a bit. And maybe 10 and 11. This is pretty quickly done. So go through these now, and I will do whatever we need to there, and then we go to the next topic where we already calculate the molar masses. Basically, this is just to get to know a little bit the chemistry on this lesson. And then ask if you need to. I think I will go quickly to the ladies from These, these all exercises we prepare. The 1 to 4, no, all of them. Not all of them. Because we said 9A to C, and I look at 9 and I'm like, I don't have a clue. I think different sense. I've seen that, but it was very poorly. I think that. Well, you can start with the first ones. Yeah. I actually don't think I can do them too.
Is that supposed to be 31B? What is 31 supposed to be?
I know that there was something, but
That's so weird.
where
What
is
is the number of programs on the house?
sorry,
What is 31? 15.
it's stupid.
No, it's the coming to the third.
This one looks so different than the ones that I have seen. So, like, why is the number up in the middle? That's strange.
Okay, oh, I get it now. So phosphorus has 15, like, atomic number, so it has 15 protons. So it has to have 17 neutrons.
But there's like the proton number is 17.
What?
Which
15?
exercise are you?
Protons 15.
Yeah, but
I mean the
you
second.
wrote- Oh yeah, okay. Of course.
Ah.
I hate this pencil.
Well, it's 57 the iron. These other things were all measurements. She's like, I did it so easy for you.
Yeah, well, not chemistry. That's the one where I always fear.
I can do regular chemistry, but when it comes to organic chemistry, the naming part, I hate it so bad. When you have to name the organic elements,
I don't know what it is.
they have the specific like systems how to name the organic elements, like the ones with the carbon in it. And they have like different shapes and these kind of things, and you have like these nonsensical rules and how to name them.
Ah, like the Pokanoxy kind of things.
Yeah.
Yeah, no, I think that's okay, but I feel like this language thing is going to be super difficult in here.
Maybe, but I don't think we have organic chemistry. Or we might actually have.
I think so. At least, I think we have like a all around basics chemistry.
I don't know. The atomic number is the amount of protons in the nucleus. Yes.
I don't know.
I think so. Yeah, I have the website. I just find the videos from.
So you can find the periodic table also in the technical formulas book. So it's here in the end of the book. the page is 186, 187. So the chemistry is here, obviously in the end. It starts from the page 184. Here are some equations. Then you have the elements and their molar masses. Basically, symbol the atomic number and the relative atomic mass of mixture of isotopes occurring in the nature. So you have the elemental masses here for the calculations. Then the next page you have the periodic table with all the explanations. So this is pretty good. Good thing. So do you want to go through some exercises now or just keep doing them? Okay, so which ones would you like to start from? 1 and 2. Okay. So the one neutron number, mass number, proton number. Yes. So this is, you also here find this one's to put the symbol, atomic number, atom mass. Yeah, it just tells you how it's there, basically. Here you can find the molar mass with more decimals, basically, more accurately than on the other page. Okay, but it doesn't tell, so we can just mark mass number. This was how it was. This would be 35. See that? Like, then the proton number is 17 to the other corner. And here I put the element. Electron number is 18. Ah, okay, this is not exactly the same. Doesn't matter. So first, let's take the how do you find the elements, basically? What is this element?
Mm.
17. Yes. So you just follow these numbers here, yes? So this is always what it shows here is the atomic number, or how many protons it has. So then that would be chlorine. So it said the mass number, I'll just write it here. Mass number was 35. Then the protons, it had 17. That means that it has neutrons, the rest. So it's the 35 minus 17, yeah? So then that would be one more neutron than proton, yeah? And then it said that it has electrons. 18. So this is it said which is isotope is. Okay, it has neutrons this much, but then how would you mark it if you would have it just as a chlorine like this? What do we need to put here? It's actually an ion. If there's one more electron, then minus, yeah, you just put the minus there. One minus, one electron more. And this is actually how it wants to be, because it wants to be this, yes? Then it has the full core, okay. I obviously translated this with ChatGPT. It made its own thing, electron number 18, whatever. Well, that's good. Using it did the correct way. Not the correct way, the same way as in the book. It actually, when I was translating it, did some good exercises of its own as well. So, number one.
Could we check the periodic table?
Okay.
If I look at the chlorine thing,
Mhm.
how do I know that it's 18 electrons again?
You don't know it from here. This is what my lovely ChatGPT friend has decided. It's what it decided itself. So of course, if you check it from the periodic table and you take the chlorine, you know that in the pure substance there is the same amount of electrons as the protons. But now it wanted it to be 18, so it means that it has one extra. So it's not actually the elemental chlorine anymore. It has reacted with something, and it has taken one electron out of it. And this is what these ones do. The ones that are on the group 17, they want to have the, the full core, and they want to have one more. My friend wanted it to be 18. 18 electrons. Which made it a more interesting exercise. Calculate the number of protons and neutrons in the following atomic nuclei. We can take a couple of these. So I have the P. And of course, here I can also write what was this. It was chlorine. Then I have the P, and then I have here the 31. And then I can check from here, what is the P? It seems to be phosphorus. This is actually a lot. Oh, what a name. More interesting to write this in English. Mass number then was this thing there in the left corner. 31. So then I check how many it should have. Here would be the 15. That's the protons. 15, and then I have, what did I want to know? Of course, the neutrons. So then that would be the 31 minus 15, that would be then 16. And then if I know this is a pure element, so then I have electrons also, the 15 here. So this is exactly the same for all of these, just to figure out where they are. This is and then I can again check from here. Iron seems to be that. Maybe I already knew. 57 was there, and it has the 26. It's iron and mass number. So now this is just the mass number here. the 57 is the one of the number of one isotope is not the molar mass. Protons, oof, I shouldn't talk at the same time when I write. 26, and then I have neutrons. 57 minus 26, which would be 31. And of course electrons I have the 26 as well. So now then this number here, which is the molar mass with many decimals, this is the what is it like the now I'm missing a word. But when you calculate how many different kinds of isotopes it has, and then you make the what is it called? What do you make of them? It's very simple. It's very simple word. Okay. This is what it has when you calculated everything and then you make the, what is the keskiarvo? Average. So then this is only one isotope that has this, but then the average of everything existing in the nature is what it shows there. Okay. And that's what you use in the molar mass calculations. Okay. So you know how to do this now. Maybe we don't have to do the rest. So that we have, what is right? Or then if you want to do them, you can. Okay, and then there would be an ion. So then the tree, there would be proton number is 20. 20. And I have electrons less. Only 18. So then I again go to my periodic table and I check the 20. Seems to be calcium. So then this is Ca. And then now I know which was the calcium. And I know that it has 2 electrons less. So it must have a positive charge. Yeah, I put there plus. And what else should I put there? Number 2, yeah. 2 plus. Because it's 2 less than it should have to be neutral. And then I have protons. How many? 35. And electrons 1 more. 36. And then again, seems to be this. Bromine. So what do I do now? Again, there's 1 more. It's just like this, the same as here. I just put the 1 minus there. Yeah? Good. And again, the same, the 4 is exactly the same. So if something has protons, it has 25. Then it has neutrons 30. And then I wanted, obviously, maybe the mass number because it wanted me to write it. So then this would be 55. Then I can check what it is. This one. So I write it there, Mn, which was manganese. Manganese. And then this, if I maybe wanted me to put this here and electron configuration, then you can think about the electron configuration, what it has there now. So now it wanted me to already write these things like this. So something's at the S, something's at the P, something's at the D, maybe. Looks like there's something at the D, but we don't go to these things because I don't know if you need them in this school anywhere. Most probably you don't. If you do, then probably you'll go through those there. So here, just an example, if we want to write that, let's write that. I have electrons, of course, there, the 25. So I have to stick them somewhere. Then I start writing that, of course, I have 1s, I have 2. Then I start filling the 2s. I have 2. Then I start filling the 2p. And there I have 6. Then I start filling the 3s. And there I have 2. Have you been doing this before? Never. Sort of. Yeah. Okay, so this is just how the electrons go to these orbitals. So they go to the orbital where there's the lowest energy. And they fill the orbitals in a certain order. And this is the order, basically. And then for some a bit more complicated stuff here, maybe these transition metals, you might have something that you have to consider. Usually you don't have to consider anything. So then I would have the 3p, 6. And then I would have the 4s2, and then I would still have some on the, and this would be 3D, which was weird, but the 4s was basically lower in energy. The S and P and these stuffs, they come from the shape of the orbitals. And the orbital was the probability of having electrons somewhere. So, but this is something that maybe you'll find out somewhere later more. So now this is what it's filling here. So I was just checking it from here, basically. 1, 2, 3. So these were the S's. These were the P's. Then I go to the, again, and now I know that this is the D, and this is, for some reason, it's the 3D. And then I can just calculate how many was still there. So 1, 2, 3, 4, 5. Has to be on the 3D. And then I can still calculate if I got totally the 25. So there would be 10. There would be 10, and then there would be 5. So I managed correctly. Yes? Okay. So this is what it means, the electron configuration. Okay, so then the 8. How many electrons do the following atoms or ions have in their outer electron shell? This is maybe a bit more something maybe you need to know. So then I would have something like this, 2 plus. So then I have to, of course, go here and find the Ba. What is the Ba? Seems to be here. Barium. And it has 56 protons, so I can start writing. I can put it, well, maybe I just write here. Protons, it would have 56. Then if it has electrons, 2 less, yeah. So it would have 54, obviously, then the electrons. And then on the outer shell, I can just check it from my book. So now it used to have these, but they are not there anymore. So then I go to here, xenon. And then this is maybe this gets a bit complicated because now it looks like if you take a look at the outer shell, it looks like it has really a lot of electrons there. If you calculate all of them, but then if you somehow know that this was, because this is already the 5 there, so this was 6, this is 5. Then I would know that this was actually the 4D, so I wouldn't calculate this as the outer shell. So then I would have only 8. Does this sound a bit dodgy now? Yeah. Maybe we don't need to know this much. Okay, we don't need to maybe know this on this course that much either. We can take one more example and then do something else. Let's take the next, the Na plus. This is again plus. Then I check the Na there and seems to have 11. So protons, I have 11. Then the electrons, I have 1 less. So I have 10. This is a lot simpler. So it used to have this. Now it doesn't anymore. And then I check how many it can have on the outer shell when it lost the one that was still there on the even outer shell. And it looks like it's 8. And now it makes sense, yeah, because there's not this thingy there. It's just this 1, 2, 3, 4, 5, 6. 3, 4, 5, 6, 7, 8. Yes. Yeah. Okay. 8. Okay, what were the other exercises? The following electron structures are the electron structures of atoms or elements important to the electronics industry. Identify the elements. So here now I showed you how this goes. So to figure out which element is this, let's just do the 8. You just calculate these small numbers together. And then you check from the periodic table. Because it has the exactly same amount of protons as electrons. Yes, because this is not now an ion. So this is an atom. That's always called an ion if there is less or more electrons. Yes. Does this still make sense? Okay. So we can check the first, for example, there. You will do more chemistry. That's part of your curriculum, isn't it? I don't know how how deep you go there. That remains to be seen. Okay. But this is only 3 credit course, so we can't really. So I just calculate together. I had there 1S2, 2S2, 2P6, and then 3S2 and 3P1. And then I just calculate these small numbers together. So there is 10, 13. And this is an element. So then I know that the protons, it has also 13. And which one has 13? Then I just check from here. Seems to be the aluminium. Aluminium. Okay. That's all on this course about this subject. Then we can we just check what means period and group in the periodic table. So we have 4th period, 2nd group, and then we go and check here. And now it says period. So these ones, the horizontal lines are then the periods, and the group is the number of the group is here always on the top. And then I check here and I have 4th period, which would be this. And then the 2nd group, which would be this. And then I come to here, calcium. Yeah, pretty easy. Easy. Well. Next, what does it say? 5th period, 1st group. Okay, whatever. 5th here, 5 here, and the first is, of course, would be this RB, yeah? Rubidium. RB. Rubidium. Then, is there anything? Okay, whatever. Then I would have the 5th period, no, 2nd period alkali metals group. So then I would need to basically know the names. So it was the 2nd period, which would be, this is the 2nd period. And the alkali metals are already the ones that are here in the left. And this would be the earth alkali or what? Halogens. Halogens are then on the other side, noble gas. Okay, this is the alkali metals anyway. So it was the 2nd and the alkali metals, it would be this lithium. Then it was the 3rd period halogens group. Halogens would be these ones. These are called halogens. And this is just to know, because it doesn't say it here in the periodic table, but maybe you are familiar with these names. So it was the 3rd period, which was this 3rd row here. Of course, you check there's 3 number. And I go to the halogens group, which would be then the chlorine. Chlorine. And then 6th period noble gases. And 6th period Then I just check here the number 6, and then I go to the noble gases. I know that the noble gases are here. Here. So then it would be radon. R and radon. Was there something more that we needed to go through? Name the non-metal outer shell. Hi, no. Non-metal? Well, maybe we could check that still. Do you know how to name the non-metal? You can check from the periodic table, yeah. If you need to. Because it says everything. It says non-metals, metalloids. Obviously, the rest then is metals, which is most of them. It also tells it here. Yeah. So as long as you have your periodic table, you know everything. Non-metal is which one of these?
I think sulfur.
Yes. So we can even sulfur. Let's take some other color. There would be. And this. This was the one with was. Ooh, what a name. Oops. Then it would be the and this. We still have some. Yeah. But this is weird now. Do you see something weird here in this one?
Isn't it carbon as well?
Yes. I think this is something that this made again itself. I think we had something different in the Finnish version. So if you're checking also the exercises in the exercise solutions in Finnish, it might be different. Sometimes it might be different. Okay, what can you do? It's not great, of course. But when it says the non-metal, yeah, that there might be even two. Okay, whatever. And these aren't so familiar, but you can check it from the periodic table anyway.
Is it selenium?
Yeah, that's how it looks like to be there, yeah. Selenium. And there's iron, and then the SM. SM, where do you find the SM? It's something like this. Samarium. And it's the lanthanide, and it's also a metal. Not very familiar substance. Okay, we don't have to do more of these. Let's go to the next one. Because I have them here in 2 different chapters, and now we are gonna go through all. just like that. And there should be also now the answers in Finnish, but obviously maybe some of these has translated a bit different way. We don't have to start writing. Okay, I just translated this. We don't have to start writing the formulas. This is not something that is expected to you on this course to know the chemical formula of something. You just are given that. Oxidation states, we just quickly also mentioned that you can check those also from the solutions or ask the friend which are oxidized and which are reduced. We don't go to that immediately now as well. Let's go to the how many moles. Let's go to the molar calculations. So we would calculate this, and this is actually the book exercise 6. This is something that we need to know on this course, how to calculate the molar calculations. Well, I'll just write here, exercises chapter 2. And this would be, well, in your list it was 5 and there it was 6. And now we have 2.70 grams of. So here we quickly go through, like I told you, you're not expected to name, from the name to write the like the, is it called equation, or what is it called, like the chemical, like you're not expected to know how to write this, but I'll show you how it's done. So we go to the periodic table. We know that this, if something is said like this means that this iron now has this oxidation number or charge in this compound. So I write here iron, and then I know that it's actually 3+ state. I have this kind of ion there, 3+. And then I also have their sulfate. So now I would need to know what sulfate means. And I can find it from this list of anions on the page 189. And sulfate is that there. And I write this there as well. So it has also the sulfate, SO4 2-. Then I form a chemical compound of these two. And a chemical compound like this has to be neutral on the outside. So I have to combine these two, so that I make a compound that's neutral on the outside. So how many do I need? These, and how many these? This is like 2-, it means that it's the whole stuff, everything there combined. So there's the sulfur, 1 sulfur, 4 oxygens combined. It forms an ion that's called sulfate, and it has a negative charge of 2. how many irons and how many of these you would put there? Yes. So 2 of these and 3 of these, yes? And now it's neutral on the outside. Yeah. But we didn't, this is something that is some kind of maybe knowledge that we might be able to gain also on this course, but you're basically just given, you are not expected to form this kind of things now. Now still we need a mass. So I'll write here, I know the mass of this. And it's the 2.70 grams. And then it was asked how many moles. The moles mean that I need to know the term. Yeah, I need to know the amount of substance. Huh? So that, like, how many times in this is the amount that is in 1 mole of these kind of constituents, these kind of this is 1. And then do you remember the Avogadro had calculated something like 6 times 10 in the power of 23? And that was the 1 mole. So how many times that amount is there? Or is it actually in this kind of amount? How do I get it? So here is this amount of substance. So N means amount of substance or moles, chemical amount. And amount of substance is calculated from mass and molar mass. So mass divided by molar mass. A molar mass is of course grams, a molar mass is grams per mole. How many grams 1 mole weighs? And the 1 mole is what is the Avogadro constant? Where do we have the Avogadro constant? Avogadro's number here. So 1 mole is this many of the particles. This many per mole. That's quite a lot. Okay. How do we get the molar mass? From here, yeah? You just check every element, like here, Fi, how do I say? Okay, Fi. And then it's the iron. Also, or then I just take it from the periodic table. Here I take the molar mass. 50 5.8 grams per mole. What do I need to put there as a multiplier? There's 2 of these, yeah? 2. Plus, then I have 3. So let's put the multiplier first and then a bracket. And then there's in this whole thing that I have 3 of is 1 like this. That was the sulfur, and I find the sulfur molar mass from the periodic table. 32.1. 32.1 grams per mole. Plus, then I have 4 of the oxygen, yes? So then I just check the oxygen here. That's 16. Four times 16, and that's also obviously grams per mole. And I get the molar mass. Are you familiar with this kind of calculating from previous studies? Okay. This is not difficult yet. Or does it seem difficult at the moment? No, no. Pretty simple. So I just calculate them all plus 3 times and brackets. This is 32.1 plus 4 times 16. That was the bracket. Did I put there 2 times the other thingy? Yes. Blah, blah, blah. And then I get something. 399.9 grams per mole. That's the, so 1 mole, which was the Avogadro's number, the whatever 6 point whatever times 10 in the power 23 is actually almost 400 grams. So it looks like I have quite, like I don't have that amount. I don't have a mole. Well, how many moles? Then I just calculate this. So the mass was 2.7 and the whole thingy would have weighed almost 400. There I get the moles, and then I just then get some number. There. Well, it was quite a lot. Let's 5 something moles times moles, and then I just say, maybe I can even write it like this. 5 moles. Whatever. Not quite a mole. Liter of water at 20 degrees. How many moles is there? Are you hungry?
Yeah.
1 liter of water, 20. And then I know from the physics that I can check it from here. Properties of liquids. Density at 20 degrees, water is 998. So density is 998 kilos per cubic meter, because this is how it's done in physics, which is also let's put it in another 0.998 grams per liter or cubic decimeter, yeah? It's almost a kilo. I usually use the 1 kilo per liter, but now it's a bit more accurate. So I have the mass of water. That would be, kilograms, sorry. Once I write it once again, this would be 998 grams. Now this is correct. And then I just need the molar mass here. And I can check it from my equation table. So it's twice the, what is the hydrogen? One plus, that was 16 grams per mole, which is 18 grams per mole. And then now I get more than 1 mole. So that was my mass time divided by molar mass, and mass was 998 grams, and then that was 18 per mole. So I get something. What do I get? Yeah. 55.4 moles, which would be whatever accuracy I now had. I had a great accuracy, and I said it's 55.4 moles. So in the liter of water at 20, these constituents there, I have 55.4 times the whatever 6. It was here. 6 times 23. Yeah, of 1 like this, which would be the, how do you draw it? There was a big oxygen and small hydrogens there, yeah? That was the O, and these were the H's. Yeah, quite a lot. Would you like to do the C at home? Yeah? And then we go to eat. The best time of the day. Okay, so what do you think about the chemistry now? Not too bad? Yes. At least the calculations are really simple. You just have to know what the things mean again. The calculations in physics are pretty simple as well. Well, you have the Jaakko, so it's a bit different. It's very practical, yeah.